Hey everyone, welcome back to another video, and today we are starting with arrays. So we'll start by what is array, what are arrays, and we'll look into array lists, we'll do some questions, we'll do some really nice things today. So let me just create a new structure, basically a new folder. I need to create a new project, and next in community classroom I can create lecture 8 or something in the lecture number 8, arrays. So in this session, if you don't know what arrays are, we'll learn we'll dive into it from the basics, why we need arrays, what is the syntax of arrays, and how this thing, how we can code in it. We'll also do some questions. We'll also see how the memory management works for arrays in Java, and we'll be doing some nice things. We'll see dynamic memory allocation. We'll see array list. We'll see how we can input from arrays, how we can output from arrays, and I'll also show you a little bit more about array lists and all these other things. So let's get started. Finish. That looks good. All right. So the first point that we will cover in this session is why we need arrays. Okay. So let's say the question is store a roll number. Okay, we love questions over here. So we say store a roll number. How can you store a roll number? So you can just say, hey, if you want to store a roll number, you can just do something like int a is equal to 19. Very simple. Another question is, let's say store a person's name in some sort of a data type, data structure, So you can say, okay, if you want to store one name, I can just store it in a name variable. I can say Kunal Kushwaha. Okay, so many things you can do. But now the question is, store 5 roll numbers. Store 5 roll numbers. How are you going to do it? Int roll number 1 is equal to, let's say 23. Int roll number 2 is equal to 55. Int roll number 3 is equal to 18 or whatever. Imagine the question was store 500 roll numbers. Would you write this line again and again? Would you declare and then initialize this again and again? Would it not make sense if there was a sort of a data structure where I could store this collection of data types? We can use an array for this. What is an array? An array, it's basically a collection of your data types. It can either be primitives or your objects, even complex data types. Whatever you want to store, you can store it in an array. Okay, so basically the syntax looks something like this. So basically here you will have the data type. Okay, brackets basically means that this is an array. So example, here I'm saying int roll number. So in this case I will say int brackets. Brackets means it's saying that this reference variable is of an array. Similarly, R and O is a reference variable. Here I can say variable name is equal to new data type size. Let's look about it for a second. Okay, let's look into it for a second. Look at this particular syntax over here, which is the declaration syntax. So basically, if I say I want to store some roll numbers, 5 roll numbers, store 5 roll numbers. I will explain in detail how this thing is working internally, how the memory management is happening, how this is mapping to the object or whatever, what is this new keyword, what is this size thing, everything I'll explain. Don't worry. So I'll say int roll numbers are integer, so I can say int, I can say roll numbers is equal to new integer 5 roll numbers. Or you can also directly write this int roll numbers 2 is equal to, directly you can write some roll numbers like 23, 12, 45, 32 and 15. Let's look into a few things. point number one, for people who are taking notes, point number one, this data type basically represents what is the type of data stored inside the array. So array is what I already mentioned. It's like a collection of data type. You cannot do something like this. You cannot do something like, okay, first two elements of my array will be integers. Second element will be a string. You can't do that. So this is point number two for people who are taking notes. Point number two, all the type of the data in the array should be same. You cannot mix and match data types. Like, okay, first element will be integer, second will be float, third will be string, then again integer, then again boolean or whatever. No. If you are making an integer array, it will contain integers only. If you're making boolean array, it will contain boolean only. If you're making an array of string, it will contain string only. Okay, if you're making an array of some complex data type, like your own data type, which we will do in object-oriented programming, in that case, it will be of data type only. And where does that data type is defined? Where is it defined? It's defined over here. So this int bracket basically means RNOS, this reference variable, is pointing to an array object that contains type integer elements. Okay, so this thing is explained. This thing is explained. How this is pointing to the memory and everything, I'll explain in like a little bit. So why we need arrays, that thing is done. And what are arrays, that thing is done. Syntax is done. Okay, so one more thing I want to share in syntax is that, how this thing is actually working. So basically, this reference variable, it's going to be pointing to this array object. So this right hand side thing that you have over here, it's the object and this is the reference variable. Let's dive into it. Let's open this up and look at every single thing in detail. So the thing that is happening over here is something like this. If I break down this step, this is known as declaration of array. Okay, so here what is happening? Here what is happening? Here ROS is getting defined in the stack. Okay, it's just getting defined like, hey, there's a ROS reference variable. Currently it's not pointing to anything. So we need to point it to an object. Actual memory creation happens here when I say ROS is equal to new integer. This is actual memory creation. Actually here object is being created in the memory, heap memory. We already mentioned in the few sessions. If you want to see the complete DSA playlist, check out the links in the description. So basically this is just the declaration and this is the initialization, basically initialization. Here the actual object is being created in heap. Okay, so let's look into it in a little bit. I'll create an entire diagram and explain it to you. So let's see how arrays work. Let's see what are these indices, how we access these indices, what is this heap and stack I'm talking about. Let's create a nice diagram and explain this. But this is the syntax to create an array. You have to mention the size over here, or you can directly just write the arrays like this. If you don't mention the size, it will give you error. Okay, let's look into how these things are working internally. So when I wrote something like, int roll numbers or whatever, I can just say int ARR also. Let's say int ARR, whatever, is equal to new integer size, colon. This is what? Data type. This is what? Reference variable. This thing is what? Creating the object in heap memory. Creating the object in heap memory. Okay, so that is how this thing is working. Let's talk a little bit more about like how it's working internally and how these things are actually being, allocated, how the memory management, works in Java. So I told you previously the things that are on the left hand side of equal to, that is like at runtime. That's like a shortcut to remember this. So this initialization and everything happens at this declaration and everything like happens at runtime. Actual memory object, like the actual object that is being created in the memory, in the heap memory, And if you want to learn about heap memory, stack memory, we have a separate video on that already. That happens at runtime. So this happened as, sorry, this thing happens at compile time, and this thing happens at runtime. Compile time, the actual object creating in the heap happens at runtime. So this is basically known as dynamic memory allocation. What is dynamic memory allocation? At the runtime, memory is allocated. That is dynamic memory allocation. Okay, this thing happens at compile time, this thing happens at runtime. Internally, it works something like this. So yeah, I already talked about like dynamic memory allocation. So assigning the memory space during the execution time or like the runtime. Internally, how is it thing? How does it work? So basically, you have the stack memory in which all the function calls and reference variables go. ARR will go over here, and the actual array object, something like this, 3, 18, 9, 2. This will be pointing to this object. Okay, so this is the reference variable, and this is the object basically. Okay. Yep, it's recording. Cool. So whenever you want to get an item from the array, so when you say I want to get the first item, one thing you have to notice is that the array indices, if we talk about the indices, if this is like the stack memory, this is the heap memory. Okay, we talked about this in detail, heap memory, stack memory, JVM manages and all these things. I hope people who are regularly following the course, they are able to understand. Very simple stuff. We went into it in detail when we were doing the Java architecture. Okay, so array representation internally, you can imagine something like this. It's like somewhat like this. Okay, a box of collection, and let's say we are taking an integer array, for example. Can I contain anything, numbers, random numbers? Okay, so in many other languages, these blocks of memory, so this is a simple memory block, another memory block, another memory block in your RAM or whatever, this is stored continuously in C++. Okay, so array in C++, it's like a continuous memory allocation. What do we mean by continuous memory? Because in your RAM, you may have some cells like this. Okay, in your RAM, you may have some cells like this. Each cell is going to have an address. Okay, each cell you're going to have an address. And in the array, basically all the cells of the array are continuous memory allocations. It's not like first 3 elements will be here, next 3 will be over somewhere over here, skipping these 2. No. This is how it works in C++. Java says something different. In Java, there is no concept of pointers. You cannot get the address or anything. So it totally depends on the JVM, whether this is going to be continuous or not. Okay. Why? Because of this reason. We know, point number 1, we know that array objects are in heap. We know this because we know that objects are created in heap, not just array objects, all the other objects, also that we'll be making of, like, let's say object-oriented programming and stuff. We know that those will be stored in the heap section. So that is something we know. And the second thing we know is that if you check out the JLS, which is the Java language specification, where they have mentioned about the internals and workings of Java, in that they have specifically mentioned that heap objects are not continuous. Okay, there is no like confident proof of this, like it may continuous, maybe not continuous, whatever. They have mentioned that heap objects are not continuous. You know what continuous means now? Okay, it means that the cells memory are like one by one allocated, not like something is missing in between for the object. Okay, point number 2. Point number 2, we know that heap objects are not continuous. I believe you know what continuous is now. Continuous basically means if this is your RAM, something like this. Continuous basically means if this array is allocated in C++, it means that it will be allocated for continuous blocks like this. It will not be like index number 1 lies here, another index lies here, another index lies somewhere over there. No, it will be continuous block of memory. But heap objects are not continuous. Java says that. Okay. And the heap is the runtime data area from which the memory for all the classes and instance of all the arrays is allocated. We also talked about this right now, dynamic memory allocation. When your program after compiling, so basically the declaration happens like at compile time, and when it's like actually creating the memory, actually assigning some memory, actually creating that array in the RAM or whatever object memory, that happens at runtime, dynamic memory allocation. Okay, point number 3. Point number 3, dynamic memory allocation. Okay, so heap area is not continuous, and we know that array objects are also in the heap area. Hence, array objects in Java may not be continuous. Okay, even though the definition of array says it's a continuous data. This is the definition of array if you Google it. But in Java, internally may not be continuous. If someone asks you what might be the reason, this is the reason, and you can just answer them that it depends on JVM. Why does it depend on JVM? For people who are following the course, you will already know heap memory, stack memory, all these things are of JVM only. That is the reason it depends on JVM. All right. Cool. This thing is covered, and I also covered that one more thing I want to share is like the indices of arrays. So for example, if you have an array like this and you want to get the first item, so basically there is something called index of an array. What do we mean by index? Index are just numbers. That basically means it's like the position of the array which starts from 0. So it's going to start from 0. Next one is going to be 1, then 2, then 3, then 4, then 5, then 6. If there's a reference variable ARR that is pointing to this array, and you try to print something like ARR of 0, this basically means what element is at the 0th index of this array. It's going to print you 3. When you print something like ARR of 2, so it's going to print whatever is at the second index, which is 19. Similar things goes for updation. Okay, so arrays are basically, I'll talk more about this, the mutability behavior, I'll talk shortly. But if you want to change something, if you say ARR of 3 is equal to 99, so basically this will be changed to 99. Okay, so we talked about memory management, we talked about being continuous or not, we talked about JVM stuff, we talked about the syntax in Java, we talked about what are arrays, we talked about why arrays, we talked about the declaration, so only the reference variable is assigned, and in the initialization using the new keyword. Yeah, new keyword is remaining. Let's talk a little bit more about new keyword. What is this new keyword? What is this new keyword? So new basically just means it is used to create an object. Okay, new is used to create an object. Okay, new is used to create an object. So here if I'm saying new int dash like brackets 5, it will create an object in the heap memory of array size 5. That is what new is. Okay, so this thing happens like at dynamic memory allocation at runtime. That is why this new thing is here. Or you can do something like this. If you are not using new, if you're directly assigning it something like like we did previously, 2, 18, 19, 12 or whatever, even though you're not putting new over here, this is also the Java internal syntax. Internally it's doing the same thing. Okay, internally it's doing the same thing. So new is a keyword that is used to create an object. Okay, here it's saying create an array object of size 5. It will create an array object of empty size 5. Initially when we don't put anything inside the array, we will see what is available over there. Let's try it out. Okay, so we talked about indices. So for example, here if I have something like let's say if there's initially just 5 elements and nothing is over there, if I print ROS of what is at the, let's say, first index, because it's a size 5, let's try to print this. It's gonna show 0, I believe. 0. Okay, so all the integer values, or for an integer array, basically by default it's just going to have all the 0 elements. Okay, everything is going to be 0 in it. Basically it's going to be internally like this. If it's 5 size, then 0 0 0 0 0 internally. Okay, let's try something else. Let's try making a string array, something that takes a string. I say string array ARR I can say new string size 4 maybe. Let's try to print what is inside this string array by default. Null. Okay, so this is a separate thing in Java. Null, it basically does not really represent like a database or whatever. Null basically means that it does not really have any data type. For example, it's null. For example, you can compare it with none in C++. Sorry, you can compare it with none in Python. Python has none. Here you have null basically. Okay, so people who might be having some questions about what is null, Kunal, we have never seen null before. It's not like a keyword or anything. It's like a special literal. Okay, so we talked about literals before, and it's a special literal of a null type. So basically you can assign it to any particular, like you can cast it to any particular reference type, but you can't create a null type. Okay, you can't like really declare this variable type. You can't say something like this. You can't say null a is equal to something. No, you can't create it something like this. If I try, no, null or whatever, no, can't do it. It's like a literal. Okay, it's a literal. If it's saying parseInt or whatever, you can see it's saying whatever, giving us errors basically. So it's just like a special type. It's like you can't reference it for like in primitives, for example. So for example, you can reference it to something like string a is equal to null. You can do that. A is already defined. String str is equal to null, but int num, this will give error. You cannot assign it to any primitives basically. Okay, you can only assign it to non-primitives. It's just like a special literal that is like null value. You can compare it to with none in Python. Alright. Even if you're having more conceptions about, Kunal, what is null or whatever, then basically just it's in simple languages I can just share that any reference variable that you have, by default it's going to have the null type. So for example, this is a reference variable ROS, and it is not at this line, it's not assigned to anything. So you'll be like, hey Kunal, what is the value of this thing? Well, the value of this is by default going to be null. Okay, similarly in integer arrays, by the way, we'll talk about how this thing works internally. Basically here there are 4 objects, so we'll talk more about this internally and why this is showing null. I'll explain it to you in a little bit, why this thing is showing null, why every particular element of this is null. We will share about that in a minute, but just understand that it's not a data type or anything. It's just it's not an object, it's not a type, it's just a special value which can be assigned to any reference type, and you can typecast null to any type as well, but you can't do it for primitives. Okay, it's just a special value which is the by default value of reference variables. As simple as it gets. Special value, literal, not an object or not a data type or whatever. Special value, that is the by default value of what reference variables point to. Let's dive into it. Let's dive into null and let's see why this by default everything is null over here. So internally what happens in Java is like, okay, you have primitives and whatever, that's fine, but what if you have an array of objects and not primitives? For example, if I have a string array, ARR is equal to new string, let's say 5 elements. Okay, internally what happens is internal working of object arrays, not primitives. Here you can see this is an object type, means it's not a primitive type. String will have an object in the heap memory. By the way, we already talked about this, that primitives are actually, they are stored in the stack memory only, like int, char, bool or whatever. They are stored in the stack memory, primitives. And for example, in the first lecture when we did like, stack memory, heap memory concept, that was specifically I mentioned, it was about objects and references. Okay, for example, in Python, there are no primitives. Everything is an object. So here in Java, note this, primitives are stored in the stack memory only, but all the other objects that like string type, array type, your own type, all these other things, hash map or whatever that we'll be making, all these objects or the classes that we'll be making, they are stored in the heap memory. Okay, we'll do an example of that as well. Internal working looks something like this. So you have your stack memory, ARR is available over here. So this is your stack memory, and ARR is here, pointing to the heap memory that contains the array string. It contains 5 elements. Now each particular element itself is an object, and this entire each object will be stored in different parts of the memory. Okay, that's how it works internally. So each particular thing is an object, and we know that this is going to be another reference variable. Some reference variable here for this might be something like ARR of 0. And since this is just initialized, it is not, we have not said ARR of 0 is equal to, let's say Kunal or 3 or whatever in string. So by default, we know all reference variables point to null. So that is why it's giving us null. To sum up, each particular object that we have over here, it's going to be in separate areas in the heap memory. These are just like reference variables over here that are pointing to those objects that can be anywhere in the memory. And then we have like so these reference variables, they may be like closely linked together or whatever when you're talking about like continuous memory allocation or whatever. But that is like not a proof in Java. Like, okay, it's not like Java definitely has continuous memory allocation. So this is actually an array of reference variables when we're doing object. Okay, understand the difference between primitives and objects. Primitives are int, char, boolean, and your float and whatever. And non-primitives are your complex data types. What are primitives? You already talked about it. Something that cannot be broken down. String can be broken down into characters. Array can be broken down to individual elements. Bigger complex data types can also be broken down, as we'll see in object-oriented programming. So objects are stored in heap memory. In stacks they are stored. The reference variable will point to the heap memory. Point number 1, we have discussed that multiple times. Second point, if each particular object, if each particular element of the array is an object, that it will be like located in some other memory, and the reference variable will be pointing to, it's like this array is actually just a collection of reference variables. Okay, and by default for every reference variable, if there is no value, it's null, none. All right, so let's look into it. Like for example, let's say we take something like this. So we have this array, or let's take the integer one only. Let me create a new one. This one looks a little dirty. So I can say something like input. So we'll be like doing the input thing over here. Public static void main. Okay, here you can see this is also a string array. So now you know args is actually a string array. Okay. So let's do something related to input. Let's say I'm saying integer array ARR is equal to new integer of size 5. Okay, so if it's starting from 0, if the index is starting from 0, we know that the last index value is going to be size minus 1, which is 5 minus 1, which is 4. So I can say ARR of 0 is equal to 23, ARR of 1 is equal to 45, and so on and so forth. So basically if I just print ARR of, I can say ARR of no, it's very time consuming but anyway, 2, 3 and 4, say 40, something like this, something like this, and something like this. If I print the array index number 3, it's basically going to print me, what is that index number 3? 543. It's printing me 543. Internally it's now stored something like this, something like this: 23, 45, 233, 543 and 3. Okay, very simple stuff. But if the array was like 1000 size and I wanted to fill this 1000 times this will be very repetitive. Can't we do it like easily? We can use a for loop. So I can say something like input using for loops. So basically I'm going to say for every index I starting from 0 going till where? Going to till the length of the array. Here I know that it's 5. I can put less than 5 over here because then it will go for index number 0, 1, 2, 3, 4. That is what I want to do. But many times you might not know the size of the array. So for example, you can do ARR.length. So you can see length is an integer variable that is public for in the array class. We'll learn more about this in object-oriented programming. You can see it's a length variable which represents the length of the array. So here I can just say ARR of I is going to be equal to input. We can take an input. We can say scanner in is equal to new scanner system.in. So here I can say in dot next int. So whenever you take a next integer, it's going to be stored in the ARR of I. Initially the value will be 0. Then it will print, okay, ARR of 0 is equal to take the input. Then the value will be 1. ARR of 1 is equal to take the input. Then so on and so forth. Okay, that is pretty much about it. One more thing I want to share is that you can also print this in the same way. So you can run the same for loop. This time, instead of taking an input, you can just say print ARR of I. Print ARR of I. I can maybe print it in a single line. Let's try to run this. I know it's asking for 5 elements because ARR.length is 5. So it's going to ask for 5 elements like, let's say 23, 3, 4, 6, 57. In the next line, it is going to run this for loop to print it. So it ran this for loop, took the input, then it ran this for loop, and every time it just printed it out. That's it. This is showing some highlight. It is called a for each loop. So basically, another point for you all. You can definitely just iterate over, like go through these indices, because here you're just using the index to get the item. You can directly get the item as well using an enhanced for loop replaced with enhanced for. Let's try that out. Okay, so basically this is the syntax for that. For data type reference variable in array, print that type. So basically here, I'll write it as a comment as well. Here num represents element of the array. So element number 1, element number 2, element number 3, 4. For every element in the array, print the element. For every element in array, print the element. That is what we're doing here. If I hide this, this is known as for each loop. Okay, if I type 5 numbers here, okay. Obviously, if you try to get the answer to more than 5 numbers, that will give you an array, an error. So basically, if you're saying print ARR of, let's say the last index is what? 0, 1, 2, 3, 4. So if you try to print ARR of 5, this will give you error. It's saying index out of bound. You know, index out of bound. The last index is index number 4 because the size is specified as 5. How are you printing size index 5? Index 5 does not exist. Error. So index out of bound error. Same thing if you write some negatives or whatever. Okay, cool. One more very nice way in order to print. So I showed you 2 ways to print. One easy way to print is actually do something like this. Print, there's an arrays class dot toString, and then you just pass the array over here. Array class has a toString method. When you give an array into it, it basically converts it into a string and prints that string. So you can see it's taking an integer array over here, and you know, if the length is if the length is like, if the integer is array is empty, it's just returning empty empty braces. If it's null, that's returning null. Otherwise it's using string builder. String builder is something we'll talk more about in the later sections. And here just adding comma and everything, formatting it for us, and using a simple for loop, same thing that we were doing. Okay, if I try to run this, it will just, without any for loop, internally it's using for loop only. You can see internally it's using for loop only. Nothing new over here. Okay, I just write 5 numbers here like 1, 2, 3, 4, 5. It's printing. It's adding the brackets, adding comma and everything for us. That is true. Adding the brackets, adding the comma, adding the numbers and whatever. Okay, 3 ways to print, and this is the best one. Okay, this is very nice. Alrighty, cool. Now, if you want to learn more about, let's say we talk more about, let's say we take a string array. Okay, we take a string array. You know, we take an array of objects. This was like array of primitives. Okay, this is an array of primitives. Now we do array of objects. We already did this. Let's say string str is equal to something like new string name. Sorry, not name. What am I doing? Let's say 4 size. Okay. And then I can say for I 0, I less than str dot length I plus plus. I can just say is equal to in dot next. That's it. Then I can just print it. Arrays dot toString arr. Sorry, not arr, str. Okay, let me just hide this thing. Initially, you know, when I do this thing, here the declaration has happened. Here the initialization means the dynamic memory allocation. Actually, the thing has been created in the heap, and by default, it's going to contain 4 objects in it because the size is 4. And by default, it's basically actually containing the reference variables to the objects. And those objects can be stored anywhere in the heap. I'll draw a diagram of this soon. 1 second. When I run this, let's say I just input 4 strings like A, B, C, D. A, B, C, and D. It's going to print A, B, C, D. Don't think that this is a character. This is a string. Okay, this can be a string as well. You want to do A, B, B, C, C, D, D. Internally, how it's being stored, let's look into it. So here you can see on the diagram, that is what is happening internally also. Basically, you have your, you have your stack memory and you have your heap memory. So in the stack memory, you have something like str in the stack memory, which is like pointing in the heap memory. Heap memory and actually contains a array of size 4. It's going to have 4 reference variables. Okay, some reference variables over here. There's some object AA over here, some object BB over here, some object CC over here, some object DD over here. This is pointing to this, this is pointing to this, this is pointing to this one, this is pointing to this one. It's storing reference variables to these objects. These objects can be anywhere in the heap. I hope that it is clear, and it is very simple stuff. Nothing new over here. And we have already done this many times. Already done object, heap, memory, and all these things we have done so many times. Okay. Cool. Now let's talk about multidimensional arrays like 2D arrays. How 2D arrays work, how 2D arrays are stored and stuff. So we already talked about the input. We already talked about the output in 3 ways. And you can definitely modify it as well. So if I say, even though it's A, B, B, C, D, so you can say modify. So I can say, let's say the first index should be something like Kunal. Then I print this again, so it will be changed to Kunal. So directly accessing the element and changing it. Okay, so you can definitely do that as well. This is actually directly getting the reference. It's saying this is the reference variable. That thing. This thing. This AA, this thing. Where that we have over here. Okay, this AA, this first star that you see. This is actually str of 0. This is str of 1. Next one is str of 2. Last one is str of 3. So basically, you're getting that reference variable directly over here and changing its value. Hence, the original one will be changed. Very simple stuff. We have done something before also. Okay. If you initially just write AA, BB, CC, and DD, afterwards, you can see string 1 is changed to Kunal. So original string object is changed. That is true. You're changing the original object. That is what we're doing. So you're doing something like this. You're saying, change this to Kunal. That is what you're doing. Okay. Cool. Let me see if I missed anything or not. So I believe we covered the basic stuff over here. And with 2D arrays, I'll explain it to you shortly. I already mentioned and stressed on a lot of points multiple times. We talked about how this is working internally. We talked about how you can input it like this and how you can input it via for loop. We talked about memory management. We talked about heap, and we talked about primitive array. We talked about the other type array like the OR array of objects and how that is stored internally. We talked about arrays.toString and how you can modify. One more thing I want to share is like function example. Now, one more thing, we are talking about references, objects, and all these things for so many lectures now. let's try to see how these things behave in functions. In the previous lecture, we did about, we learned about functions, and we also learned how data types and like reference variables are passed into functions. In Java, there's only call by value. And when we pass an object's reference, it's actually going to take a copy of that reference, which is going to point to the same object. Let's try that. We already did this in the functions section. So we already ran this example also in the functions section. So nothing new over here. Passing in functions. Let's make something like this. And then I can just say public static void main. I can create a function over here, static void change. It's taking an integer array of, let's say, ARR or whatever. And it's saying the 0th index, change it to 99. Let's say I create an original index array over here, integer array. It's called nums. That takes something like 3, 4, 5, and 12 or whatever. I'm saying print this. So I'm saying print arrays dot toString nums. Obviously, it's going to print 3, 4, 5, 12. But after that, I'm saying change the value of the 0th index via this method. So just pass this nums array in the method. What is going to happen over here? Let's look at our diagram. Let us look at the diagram. What is going to happen over here? We have done this many times. You might be aware of it already now. So basically, initially we have something like this. So we have nums, reference variable pointing to an object of array like this, which is 3, 4, 5, and 12. Then the copy of this reference variable is passed in the function. Let's say the name of the reference variable in the function. What is the name of the reference variable in the function? ARR, but it's pointing to the same object. And what am I doing in the function? In the function, I'm doing ARR of 0 is equal to 99. Means this object's 0th index should be changed to 99. Isn't now the original value being changed? The original one is also changed, right? Because both of these are pointing to same object. This is known as mutability, mutable behavior. Okay, so strings are immutable in Java and arrays are mutable in Java. Mutable means, in simple language, you can change the object. You can change the object. Why are strings immutable? Why cannot we not change strings? We will look that into the string module. But if I run this, it will actually change the original array as well. Ta-da! Okay, now let's talk about 2D arrays in Java. How do 2D arrays work? Basically, 2D arrays, you can imagine it as a matrix. So for example, I just say multi-dimension array or whatever. Public static void main. So you want it to look something like this. Let's say you want it to look something like this. Why am I writing the syntax? I can just directly show you. So for 2D arrays, basically if you're making a 2-dimensional array, it should be like a matrix sort of a thing. So for example, I can just write it directly. It can, if you want to print something like this, if you want to say create an array that is a matrix like this, 1, 2, 3, 4, 5, 6, 7, 8, or it's like too big. I can say 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this case, you are going to have 3 rows, 3 columns. How this works internally and everything we'll look later on, but let's first look into how we are defining this. So 1D array is defined like this with 1 bracket, 2D array is defined with 2 brackets. Okay, then I can say ARR is equal to new integer. I can pass a size over here. Let's say the number of rows that we are going to have is 3. Number of columns is not necessary to specify. Why? We will look into it shortly when we discuss how this is actually being stored in the memory. Then we will discuss about it. Adding the rows is mandatory. It's not like you are adding the columns only. No, this is not mandatory. The number of rows is mandatory. This is a syntax. Here you go number of rows. Here you add number of columns. You can definitely add number of columns as well, but it's not mandatory. Okay, cool. And if you want to store it like this, like, you know, in the hard way, we were doing it like directly. If you want to store something, so you can do something like this. Sorry, not this bracket, but like curly braces. You can store something like comma, 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 and then this 1, 2, 3, 4, 5, 6, 7, 8, 9. Things will be much more clear when we see how this thing is actually being stored in the memory. Without further ado, before we try input, output, before we try, the size and everything, whatever those things, let's see how this thing is working internally. Let's see. So in C, C++, this is also continuous memory allocation. Okay, even in 2D arrays, it's continuous memory allocation. In Java, it's something different. So in Java, it's saying if you have an array something like this, that is, it's pointing to an object, and internally it's stored something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's understand how this is being stored. Stack memory, heap memory. Understand how this is being stored. So basically, how is this being stored? Every single thing that you have over here in terms of the arrays. So basically, you can imagine this as an array of arrays, meaning the 0th index is an array itself, the first index is an array itself, the second index is an array itself. Array of arrays. You can imagine it something like this. Okay, that is how it's like actually stored in the memory. In the memory, how it's stored in the heap section, basically it's stored something like this. So if you have array like this, stored in the heap memory, like this is the main array, that is the outside array, and internally it has 3 internal arrays. This can be in some other part of the heap, this will be in some other part of the heap, this will be some other part of the heap. Same thing like we discussed previously. Individual ones are basically, just like the references to this individual arrays. So this will be individual array like 1, 2, 3. This will be individual array 4, 5, 6. This will be individual array 7, 8, 9. These are like going to be references to these arrays. That's how it's stored internally. Even if you want to do 3D arrays, that will add just one more dimension to it. You can make 3D arrays as well. You cannot visualize after 3D arrays. If you're working with higher dimensions than that, then use Python and NumPy and stuff. But you can visualize till 3D arrays. You can do 3D arrays in Java as well. You can do more than that as well, but it's hard to visualize after 3 dimensions. So basically, each particular index is itself an array, and that is in some other memory location in the heap. So when you take ARR of, let's say, 1, it's going to give you what? This will give you 4, 5, 6. And when you do the index of this itself, so when you do ARR of 1, 0, so it's going to say, okay, ARR of 1 is what? The first index of this 2D array. First index of this 2D array contains an array itself. And then it's asking what is the 0th index of that? 4. This will give you 4. Okay, I hope this thing is clear and it's very simple stuff. Next thing I want to mention that since these are individual, now I mentioned, I will explain why column size is not necessary. Column size is not necessary because how many number of arrays do you want to have? That thing should be there because that way the heap memory and everything will be created. But for individual columns, this column has 3, this row has 3 columns. This is row 1, this is row 2, this is row 3. This has 3 columns, this has 3 columns, this has 3 columns. It can definitely have variable number of columns. The size of the individual rows does not matter. It can also be something like this. Your array can be something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. It can be something like this as well. Let's try it out. Let us try this out. So I can say something like 1, 2, 3, 4, 5, 6, 7, 8, 9. Isn't it good? Individual size of array can vary as well, because each array itself is a different object. That is why it is not necessary. It will not give me error if I don't add this thing over here. The number of columns. So number of rows is 3, number of column in the first one is 3, number of column in the second one is 2, number of column in the third array is 1, 2, 3, 4, 4. Okay, that is how it's stored inside the memory. So individual ones can have the different size. Now let's look at the very basic stuff, which is known as input and output. So I can say first let's look into input. How are we going to take the input? For input, I'm going to say that 0th index, first index, second index. Okay, so when I say, for example, ARR 2D of 2, this will give me 6, 7, 8, 9. When I do ARR of 2D of 2 of 0, this will give me 6. Okay, so how do we input? We will run a for loop for every index. We will say, okay, first fill this particular array, then fill this particular array, then fill this particular array. We are doing the same thing that we were doing over here, input. This thing. We are saying take this entire input. This is an input for one array. We need to do this same thing for individual arrays. We need to do this multiple times. Let me take the scanner. Okay. So we need to do this thing, ARR. I can just hide it over here. I can make this ARR, for example. Okay. So this is something we need to do. So basically we need to do this thing for every index of my original array. At 0th index, it's going to have, hey, at 0th index, I have this particular array. Please fill this out. Initially, let's say we have 3, 3. So initially, let's say we have 3, 3. So I have something like int ARR is equal to new int 3, 3. So here I'm going to say for every row, so I can say basically for every row, what is the length of the row, by the way? And this is another important point. The length of the array, when you print the length of the array dot length, this will actually give me number of rows. So even if this was something like 3, 4, this will print me 3. Okay, cool. So here I can just say 3, 2 for now. So here I can say ARR dot length, number of rows. And for every row, for each column in every row, I want to take the input. Again, another for loop, this time for every column. I will explain this with the diagram as well. Don't worry. Column 0. This time column will be till where? This will be column, this will be having, let's say, size of 3. This will be having size of 2. This will be having size of 4. Even though in this case, every column has a size of 2. But the size of the column is varying for every particular index of the array. Let's say the array at 0th index have a size of 3. Array of the first index have a size of 2. So here we are going to say every array at that index, every array at that row, the length of that array. Every array at that row, the length of that array. That is what we want. Okay, we will run this. We will run this. Don't worry. I will completely run this. And then I can say ARR of row and column is equal to int.nextInt. Okay, let's try to run this. Let's try to see how this is working internally. Let us try to see how this thing is working internally. So we have two things over here. I am saying that initially it's a empty array of 3, 2. So basically 3, 2 means we have empty array like this. Index 0, 1, 2, 0 and 1. These are my rows. These are my columns. Okay. So what am I doing in the for loop? In the for loop, I'm saying that for row is equal to 0, row should be less than the length, which is equal to 3, and row plus plus. Then for every column in that row, now we are taking every row. Here we take every row, and we know that every row itself is an array of size 2. We know every row itself is an array of size 2. So we will iterate on this array now. So we will say for every column starting from 0, column should be less than here, less than 2, column plus plus, take the input at array of row comma column is equal to input. That's it. Program finish. Let's try to dry run this. So initially my row value is going to be 0. Then it's going to say, okay, here row value is 0. For row value 0, try to run this entire for loop. It will run this entire for loop for row is equal to 0. So row is equal to 0 right now. Row and column, let's say. Row is equal to 0 and now column is equal to 0. So it's going to say, okay, column is equal to 0. Is column is 0 less than 2? It's going to be say yes it is. Then just it's going to say add array of row comma column, means array of 0 comma 0. Take the input for that. I add something 23 over here. Then it will come out of this for loop. It will increment the column by 1. Then it's going to be like, is 1 less than 2? It's going to be like, yes it is. Okay, then 0 comma 1 should be another input. 0 comma 1 another input. Let's say 18. Value will be 2. Is 2 less than 2? No, it's not. Okay, come out of this for loop. When I come out of this for loop, this loop is now ran once. So for 0, it will now be coming out of the for loop. This outside for loop will run again. Row plus plus, this will be 1 now. When I do this 1, now it's going to take for this particular row. Call will again be 0 because this loop will run again from the start. We already talked about the scoping and everything in previous lectures. So again call will initialize to 0. Then it's going to say is 0 less than 2? It's going to say yes it is. Okay, then row comma column means 1 comma 0, take the input. 1 comma 0, take the input as 9 or whatever, and then increment the value call plus 1. Will be 1. Then okay, is 1 less than 2? Yes it is. So 1 comma 1 is again input. Let's say 27. Value is equal to 2. And then it's going to say, hey, is 2 less than 2? It's going to be like, no it's not. Okay, then come out of this for loop. This for loop for 1 is over. Row plus plus, row will now become 2. Then it's going to check, is 2 less than 3? Yes it is. Okay, then go inside the for loop. Again the for loop will be initialized. Again call is equal to 0 will be initialized. Okay, let me zoom in like it a little bit so that you can see. Okay, and again it will be initialized. So it's going to say, okay, call of 2 comma 0 is input. So 2 comma 0 is input. Let's say 37, 33 or 37, whatever. That's going to be like, okay, plus 1. Is 1 less than 2? Yes it is. Call of 2 comma 1 can be something. 2 comma 1 again input. 2 comma 1 again input. Let's say 8. Then it's going to be 2. It's going to be like, hey, is 2 less than 2? I'm like, no it's not. Then it's going to move out of this. Value 3. Is 3 less than 3? No it's not. Program over. Array is filled. So in simple language, outer for loop, it's iterating each row. For every row, I am iterating every column using another for loop. So we already understood how to take input in a one-dimensional array, in a 1D array. I am doing that same thing for every row. Okay. So here I was basically saying this 2, instead of this I was just saying array of row dot length. Imagine it was something like this. Okay, let me just array of row dot length. So imagine if it was something like this. If my array was something like this, let's say this is the outside like array. First one contains, let's say, 3 elements. Second one contains only 2 elements. Third one contains like 4 elements. So here for the outside for loop, it will be like for row is equal to 0, row is less than 3, row plus plus. Now for every column, what is it going to do? Column is equal to 0. Column is less than what? 3, 2 or 4? Size of the row. Size of row. Column plus plus. Input. That's it. For example, when you run row for the very first time, will be 0, column will be 0. Column is going to be less than size of the row. What is size of array of 0? 3. Hence this will go till 3. 0, 1, 2. When it will run again for I is equal to 1. What is the size of array of 1? Actually equal to 2. So it will actually go till less than 2. Means 0 and 1. Okay. Very simple stuff. That is the reason we are using this thing. This is the reason. It's actually saying individual size of the row, only we need that many amount of columns. Obviously, if first row has 3 columns, take input of 3 columns. If second row has 2 columns, run the for loop for the columns twice only. If third row has 4 columns, run the for loop 4 times for input. Okay, cool. So that is what we are doing over here. And let me now also show this thing in action. So basically, how do we print this? Do the copy. Instead of taking an input, now we can take the output. So instead of taking the input, just say print this thing. Print this thing. After every column is being printed, after every row is printed, so this is iterating over every row. For first row, it's going to say, okay, print the first line. For second row, print the second line. So my question to you is, when the first line has been printed, let's try to run this first. Okay. Let's try to run this first. So I say I can input something like 1, 2, 3, 4, 5, 5, 6, 7, 8, 9. Basically, it was taking just 3, 2, so it's taking 6 only, so that's why it's printing 6. But let's say I make an array of 3, 3. So like the 3, 3 is 9 elements, so I can just input 9 elements over here. It will definitely print all the 9 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9. Why is it not printing in a matrix form? Because you did not add a new line over here. After printing every single row, should you not print a new line? Print row number 1, then print new line. Row number 2, print another line. Now it will look much better. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now it's looking like a matrix. Print row number 1. When it comes out of this for loop, when it prints the entire, this row, it comes to the new line, new line, new line. Okay. We also saw that you can use arrays.toString. So can't you do something like this? Another way to print this can be, first of all, enhanced for loop. Here basically enhanced for loop, it's very simple. We'll talk more about that later. But here what you can do is, actually we can replace this with arrays.toString. What do we need to pass? Every individual array, array of row. That's it. Because this is actually printing just this entire internal for loop is same as this thing, right? Same as this thing. So if I'm able to replace a single thing with a, arrays.toString, why can't I do this with the other one? Let's run this. Three, 4, 5, 6, 7, 8, 9. So for every line, it's running the arrays.toString, because every single individual element of the outside array is an array itself. This thing is an array itself. ARR of 1, ARR of 0, ARR of 2. Array itself. We discussed about it a lot of times. And if we want to replace it with an enhanced for loop, so basically if I want to iterate over this array, the outside array, if I want to iterate over this outside array, what is the type? What is the data type of every element? You tell me. I mentioned it again and again. In the ARR array, every element itself is an array. And we put the data type over here. Previously, we were saying every element. Where is the enhanced for loop? Yeah. So here the data type comes. Data type basically means in this array, what is the type of data of every element? In this case, it was integer. In this case, it is an array itself. Array itself. A for every array in ARR. Just print this array. How simple is that? Enhanced for loop. Gonna do the same thing. Just the data type will come over here. Okay. So example, if you have something like, this string thing. So you can do for what is the type of data type of every single element in this string. It's of a string data type. So for string element or whatever name you can give inside the array, print that element. Iterating just for enhanced for loop. Okay. And in this case, for the outside array, the main array, every single element itself is an array. That's why we're saying, okay, the data type of every single element in this array itself is an array. So we did the input and we did the output as well. That is pretty much about arrays. More than enough for you to get started. And I think I will be doing separate lectures on like the questions part. So after this, we will be doing searching, sorting, and then we will be doing interview questions. So there will be just a single video after every topic in which we will only do questions, so that in the future, if you want to learn concepts, you can watch this video. If you want to learn about questions, you can watch the questions video. We'll be doing questions related to sliding window, two pointer method, sub array questions, binary search, cyclic sort, sorting and bubble sort, quick sort, whatever, and all these things we'll be doing. All the questions we'll be doing as well. We're doing binary search. On that, we'll be doing tons of questions. We'll do modified binary search, rotated binary search. We'll do so many things. So make sure you like, share, and subscribe, and check out the links in the description below. Before we move on to the next topic, I can also share with you the thing I was mentioning about, like, why are we doing this thing, ARR of row.length? Why are we taking individual length only? Because it might be the case that you are trying to, print an array like this. Let's say column no fixed size. Okay, let's say the column is not a fixed size. So I can say my array is equal to something like this: 1 2 3 4 5 6 7 8 9. What if I want to print this? I can just say, if from traditional way, for using a for loop, I want to print this, I can say, okay, I know that there are ARR.length number of rows. I know that. I know there are ARR of length number of rows. But how many columns are there? In the first one, there are 4. So I can say, for every column, what is this going to be less than? Is it going to be less than 4, 3, 2, or 1? Or what? No, it's actually going to be less than what is the size of that particular level. What is the size of that row? Size of the first row is going to be, or second row or third row is going to be, array of what is the array at that particular row. So for, if the value of row is 0, then ARR of 0 is going to give me 4 dot length. Print ARR of row, comma, column. I can add a nice over here, and then I can add a new line over here. This is the reason we were saying array of row dot length. Printing it very nicely. First, the value of row will be 0. Then this for loop is going to run till the size of the array at 0 row, which is 4. So it will be actually, for first time it will be 4. Second time it will be less than 2. So it will only be for 0 and 1 running twice. Then it will be 3. So it will only run for column 0, 1 and 2. Okay, that is the reason we're putting this over here. Now let's look into array list. Now, what is an array list? Before we jump into what is an array list, let's consider why we need an array list. So basically, the idea is that here arrays are of fixed size. Okay, we know this is size 5. We have to give a size. But what if you don't know how much size you need? What if you don't know that? What will you do then? You just want that, hey Java, please handle the size for me and let me input any number of elements that I want. If this is your problem statement, then you can use something known as an array list. If you have done C++, it is similar to vectors in C++. So array list is actually a part of the collection framework, which we'll do in more detail when we do like the object-oriented programming, and it's in the java.util.package. So basically, if I create array list example, basically when you don't know how much size you want. And we will also see how this is working internally. You might be having questions. Hey Kunal, how is it like, that you're not specifying any size and it's doing automatically all these things and taking as many inputs as it likes? Let's look at the syntax first. Syntax is basically like this: array list, data type, so it can be integer. Let's say I want to create an array list of integers. I can say list is equal to new object. So I'm creating a new object of this new array list. This is the syntax. You can also write the data type over here, but it's not mandatory. Similarly, for one more thing I wanted to share was in the integer type. For C people, you can do something like this as well. This is also valid, but it's not like the Java way to do it. This is much more clean. Okay, putting the braces after the variable name is also fine, but this is looking much more nicer. Okay, so in array list example, basically here, this is the syntax. Array list is a class. You can see here, it's a class because it starts with a capital letter. It extends abstraction. We'll turn up in object-oriented programming. We'll look into what is extends. We'll look into what is implements. We will also look deep into what interfaces are and what is this list and what is this serial and whatever. Do not worry about it. For now, it is just a class. Just focus on that. Okay, so it's in the collection framework, and here I mentioned in the java.util you have the array list, and it's in the util package part of the collections framework. You can see over here. This class is a member of the Java collection framework. So there are like list, linked list, and vector, whatever things that we are doing. They have provided these. So basically what is collection framework in simple terms? In C++, you might have heard people say like, hey, with comparative programming, we have all these things defined already. We have all the data structures and everything written for us by some people already. We can just use this in comparative programming to make our things, make our lives easier. Similarly, there's a collection framework. All the other amazing data structures like linked list, stacks, like your hash maps, sets, and all these other things. Java provides the implementation for this in the collection framework. So we will be using collection framework. We will also be writing the entire data structure from scratch as well. When in the future we'll be doing data structures. Okay, that's the collection framework, and one of the classes that are a part of it is known as the array list class. Okay, so this is slower than like the standard array. You can input anything you like, as many things as you want in it. If you want to give an initial, this is basically a constructor which we'll look more into when we do basically the object-oriented programming. So we'll look into constructor. Here you can pass the default size. I can say let's say 10. So initial capacity 10. Okay, for this, how this thing is working. So there are two things you might be confused with right now. First, let's look into how we can use this. Then we will look into how this is working internally. Kunal, how are you making sure that this will never be full? That we will also consider after this. Okay, so let's answer the first question first, like how do we actually work with it? So basically, here when you're adding the type, okay, this has something to do with Java object-oriented programming with like the interfaces and stuff and like the generics. We have generics as a separate topic. So for now, just understand what we are doing. How we are doing it, we will do it in generics on object-oriented programming. I know I say this a lot that we will do it in object-oriented programming. Trust me, if you see the syllabus, generics is available over there. So basically generics is just saying what is the type of data that you can store in this list object. It's saying you can only store, let's say, integer. If I just write string over here, then you can store string over here. You can definitely not write it as well. It's like totally fine. You can just skip this as well. That is not good practice. Okay, this is not good practice. Okay, good practice is actually write some data type that you're using. So here you cannot pass primitives. You have to pass the wrapper classes. We talked about wrapper classes already initially, but in detail we will talk about it in object-oriented programming. So it's like the wrapper class for the primitive data type int. Okay, so you cannot use the generic stuff like the specifying the type of the array list. You cannot use you can't use it like this. You cannot add primitives over here. You have to add wrapper classes. It has something to do with object-oriented programming. We will consider that later on. In the constructor is basically saying that all the initial values that you want to define specifically for this object, in that you can add it in a constructor. So this is basically a constructor being called. Forget about me saying constructor. Forget constructor from your mind. Don't worry about it. We will cover it in detail in object-oriented programming. For now, just imagine that a new object is being created of type ArrayList, and this is a reference variable which is pointing to this. Okay, That is it. All right, let's see how we can add stuff into it. So we can say list dot. So this list object has a method called add. So it's saying add. I can add something like an integer to it. Like right now, I can add something like 67. Okay, I can add something like as many things that I want. I can do it again and again. I can say add something like this, add this, add this, add this, add this, whatever you want to add, as many things as you want to add. No initial sizes specified. If you're saying, hey Kunal, you have specified 10 over here, okay, does not matter. Hello, add as many as you want. Let's try to print it. By the way, you can directly print list, because when we were doing arrays.toString, whenever you print a complex object, basically we will go in depth of toString as well in object-oriented programming. I know I say this a lot, how toString is working, how these things are working, why are we doing toString, how can we write our own toString. Everything will be covered in object-oriented programming. This internally calls its own toString as well. Okay, so don't worry about this. Again, internally it's saying value of, and it's again calling the toString method over here of any object that you pass over here. Object class we will look into detail. Every class, inherits the object class. It's like the main top level class. Okay, so we'll talk more about that later. Okay, so if I print this, you can see it will be able to add all these items. So many, all the items are added. You are like, hey Kunal, you said the capacity is initially 10. How are you adding more than 10 items? Let's see how this thing works internally. So it is very simple. Let me just first show you some more functions and stuff. So maybe I can show you something. I did like too many. I'll just remove these, quite a few, just to make things simpler. Okay, add as many as you want. I can, let's say, initial capacity 5 or whatever, does not matter. You can print the list, and you can also update something. Okay, so adding is done. So you can do list dot. When you do dot, you will see all the functions you can apply on this list object or of this reference variable. If you want to create it to an array, you can use toArray. If you want to add all the numbers from some other array, you can do that. If you want to check if something is available, if you say, does this contain 654? So if I say sout list dot contains 654, does it contain 654? Yes, it does. It will give me true. True. If I write something that it does not contain, it will give me false. Okay, false. Other thing you can do is actually change some items. So I can say list dot update or whatever, change or set, basically. Yeah, list dot replace, I believe, not replace all, list dot set. Yeah, so if I want to check, I want to say set the 0th index to 99, for example. Now if I print this, 0th index will be changed to 99. Let's print it over here. So you can update stuff as well. $99. So many things you can do. Okay, you can remove stuff from it as well. You can be something like, hey, let's say I want to remove the index number 2. So I can say remove index number 2 or whatever. What is index number 2? 654. 654 will be removed. Gone. Very simple stuff. Okay, similarly you can iterate upon it as well. You can say, if I take the input, it can be done now in the same way like we were doing previously. So I can say for I is equal to 0, I is less than, let's say 5, I plus plus. You can say list dot add something like in dot next int. I can create in, so I can say scanner in is equal to new scanner system dot in. Okay, let me just hide this thing. Let me hide all of these things. I'm just taking the input like this, and for the print part you can just do simply like this, but you can also do something like this. I can just say s out. By the way, if you want to get an item, so basically get item at any index. For that, you can't do something like this, like we were doing previously. You have to do something like list dot get. Then you have to pass an index over here, I. Try to run this. Gonna add 5 items. Say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 print. So here you will pass the index. Okay. Pass index here. List of index syntax will not work here. Okay. Cool. So that looks good. And we have done like iteration, output and stuff as well. Let's see how this thing works like, internally, and how is it maintaining the thing that we mentioned, like so many things you can add in it. It will never be full. Let's see how it works with that. So let's see how it works like, internally, how the, ArrayList things is working internally. So when in arrays, we were talking about like list of references stuff, like when we have an array of objects, it's actually, we talked about this previously. If you have an array of object, we did an example of, let's say, the string one. So we were saying this is actually, if you have an array of object, then you have like a array like this over here. In the stack, you have the pointer and like the reference variable. Here you have the array of the object. Each object here itself is like, a reference variable pointing to like the individual objects. In ArrayList, since we mentioned not every single element can be a primitive because it does not allow it. Why it does not allow it, we'll look into object-oriented programming, but it's the similar concept that is being followed here. Okay, internally it's similar to how arrays work. So I don't think there's a need to explain how these things is working because it's exactly the same as array. But the real question is, how is it saying that no size is required? You're providing, let's say, some initial size 10, but you are able to input 100, 1000 elements. How is that happening? Why is this size not fixed? In reality, in actual, this is what happens. Size is actually fixed. Okay. Point number 1. Size is actually fixed only. Size is fixed internally. So internally the size is fixed, but what happens is when your array list fills to a particular amount, let's say, for example, I'm not saying this is what happens in Java. For example, let's say your array fills by 50%. Let's say array list fills by some amount. Then what will happen? This is what will happen. It will create a new list, new array list of, let's say, maybe double the size. Again, I'm not sure, we would have to check. Of double the size, a new empty list is created. Old elements that were in the old list are copied in the new list. Old one is deleted. This is what happens. Let's say initially your array list had a size of 3. So when you input an element, or 4, when you input an element 1, it will come over here. When you input an element 2, it will come over here. When you input another element like 9, it will come over here. Then it will be like, okay, at least 50% is full. Then when you try to input an element again, it will do something like this. It will double the size. It will copy these elements over here. Then it will input your another element that you want to add, let's say 18 or whatever. When this is also half full, it will double the size of this again. We will go into details of this, why this is constant time complexity. Amortized time complexity, this means. This particular point is for people who already know about time complexity. If you don't know about time complexity, skip this right now. We will cover this in detail. We will do the entire derivation and everything, why this is on an average constant time complexity. And don't worry about what is this Vigo. Don't worry what is constant. Don't even worry what is time complexity. We will cover it in very, very detail. But this is just point for people who might be asking questions like, hey Kunal, if it's like doubling the entire array and taking O of n time and everything, how can you make sure it's so? I know. Try to Google a little bit. But if you want the answer from me, we will cover it in the space and time complexity session. Okay, that is how it works internally. Let's see how actually it works in Java internally. So basically, if I say initial size is equal to 10, that basically means like, that after the capacity is full or whatever, it will then double it or whatever. Yeah, basically half full or whatever. Let's see how it actually does it. Would have to deep dive into it. How is the array list working? It's creating a copy. Construction in the order they are returned from iterator. There was some place where it was doing some passive array list is necessary to ensure that it holds at least the number of elements per minimum capacity. That's true, that's true. Yeah, increasing the capacity over here. Here we go. So this is a right shift operator. It's actually old capacity, and then minimum growth is minimum capacity minus old capacity. Increase the capacity to ensure that it holds at least the number of elements of minimum capacity. Okay. So here it's saying size plus 1, grow by 1. I'm pretty sure it's not growing it by 1 because that is not very efficient. I am pretty sure it's like doubling it, but I can't find the code for that. Seeing some hash code and stuff. Yeah. So it's actually adding a new capacity in the grow function. So basically grow is just taking the old capacity and creating a new capacity of the new length, which is equal to taking what? This is taking basically old length, minimum growth, and some pref growth. What is that? This is preferred growth of the array length. Okay, that is what it's doing. All right. It does throw out of memory error, like when the required array is too large. So it's taking the maximum of the minimum growth and preferred growth and taking the old length and doing it somewhat like that. Okay. So where is it? Grow. So basically it's saying new capacity is equal to exactly what I said. It's doing that. So it's basically making a new capacity. They actually have a formula for a new capacity. So it's a little bit complex. So it's saying the new capacity is equal to there's a function new length that returns the new capacity, and whatever I said, like they're taking a copy of that and adding it into the new capacity. That's what they're doing. That is fine, but if you want to see actually how they are taking the new capacity, saying the new length is equal to maximum of the minimum growth and the preferred growth plus the old length. Okay, that makes sense. Sound good? And it's not like you can, definitely increase this to as much as you want. Obviously, if you don't have the memory for that, then it will not be happening. Okay, but don't worry much about it. They have provided this abstraction for a reason. Don't be like, hey Kunal, we don't understand what you are, searching in this file. No, this is just an array list that Java people have provided us. And I was just searching for a code like how it's actually doubling or whatever it's doing. It's having some own formula. That is how it's actually doing it. That is, how this thing is working internally. The size is being changed when a particular capacity reaches. You can see it's having some preferred capacity or whatever. That was it about. Okay, you can also create like multi-dimensional array list. So I can create multi-array list or whatever class, whatever name. So here it's previously it was integer of integer array. Integer array of integer array. This will be array list of array list. So array list of array list of type integer. Of type integer, nothing new. I know by default, for every reference value is null. So if I try to print this, so I will try to apply a for each loop for every, or not a for each loop. If I just do for int, initially it's going to be empty, right? So I would have to initialize it first of all. So how do we initialize this thing? So I can say add, let's say add 3 lists inside this. So I can say list.add new array list initialized. So now 3 lists have been added. If I want to now add elements into it, so this is like the initialization part. Obviously, if you don't initialize, obviously by default the value of every single index is going to be null. So if you don't initialize this, it will give you error. For example, if I say for the first, because previously also you were initializing, right? Here also you were initializing in 2D array, in the multidimensional array. You were initializing over here. Same thing we are doing over here. So it's saying for 3, for this is also 3, I can say list.get the array list at the index I and add something to it. In.nextInt. I can take scanner over here. Scanner in is equal to new scanner system.in. And then if I just print it out, I can say print out list. See what it will be, just see what this will print. So if I run this, it will give me some input 1, 2, 3, 4, 5, 6, 7, 8, 9. It's printing out 1, 2, 3, 4, 5, 6, 7, 8, 9. So even multidimensional arrays can be printed similarly with println. Multidimensional array lists. Okay, if I don't add it over here, I will get error. Why will I get error? Very simple. Because it is saying, hey, list.getI means get the list at the index number 0. What list? This is empty. What list are you talking about? These are the lists that we am talking about. I have to actually add some lists over here. Okay. So what I'm saying is that for multi-dimensional array lists, for example, if you have something like this, it's important. So, you have like array list of array list. Initially it's empty. Null, 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 null. You actually have to add some array list over here. This will use another array list, another array list, another array list. Let me zoom out a little bit for you all. Like this. Okay. So these are the things that were not created. And this is the reason we were getting an error. We're like, you haven't even created any lists over here. What do you mean? What do you mean add? What do you mean get the first list? There are no lists over here. That is why you have to create individual lists, because individual objects. Okay. Now let's do a few questions. So let's say we did the, obviously we did the passing in functions one. We can do a swap one. So basically we can do swap. So here I can say public static void main integer array is equal to new integer, or I can just add directly. I can say 1, 3, 23, 9, 18 random numbers. I can create swap. It's going to take the array. It's going to take 2 indices. Let's say I take index number 1 as 1, index number 2 as 3. Okay, what does swap do? It does not return anything. It will just swap. So here I will pass the array. Here I will pass the index number index 1. Here I will pass index 2. The idea is just to swap this. Swap the indices at these 2 places. We already know the code for swap. Temp is equal to array of index 1. Array of, this is something we have done many times already. Array of index 2. Array of index 2 is equal to array of index, temp. Very simple stuff. Now if I try to print this array, it will be swapped. What is it? Very simple. Nothing in this question. Very simple question. Literally nothing in this question. 1 and 3 will be swapped. 9 comes over here, 3 goes over here. Index number 1 and index number 3 is swapped. If you want to swap the first 2 indices, 0 and 1, or the 0 and the last index, basically, let's say 4. 18 will come here, 1 will go at the last. What is it? Nothing. We already talked about this over here, passing in functions. Same thing is happening over here. Nothing new. Okay. Very simple stuff. We can do another simple question like maximum item. Okay. Public static void main. So you can say integer. I can just copy paste from here. Yeah, I'll just copy paste from here. Basically find the maximum item in this. So I can say print the maximum item in ARR. Let's create a function for this. So it's just going to return the integer value of the maximum item. How am I going to print the maximum item? Let's say I just assume that if we have 1, 3, 2 and 9, let's say we take it, let's say we do the code for this over here. So we have something like 1, 3, 4 and 1, 3. We have 1, 3, 23, 9, 8. I can just iterate upon this array. I can just go one by one. I can say, let's say I assume that this is the maximum item. Let's say I assume this is the maximum item. Let's say I say maximum item I assume is the first element. Then it will compare with the next element. Is 3 greater than 1? It's going to be like, yes, it is. Update the maximum item to 3. Then the next element is 23 greater than 3. Yes, update the maximum item to 23. Is 9 greater than 23? No, it's not. Move forward. Is 18 greater than 23? No, it's not. Move forward. End of the loop. 23 is your answer. Is there anything in this question? There is nothing in this question. Another question can be find the maximum item in the range. So basically here I'm running the loop from 0 till last. If I'm asking what is the maximum item between index number 1 and 3, then I'm just going to run the loop from index number 1 and 3. Very simple. Let's try it out. Let us try this out. First, let's try to find the maximum item overall. So I can say something like from 0 till last. For I is equal to 0, I is less than array dot length I plus plus. I can say let's assume that the maximum item is equal to ARR of 0. Okay, here I say imagine that array is not empty. Okay, if it is empty, you can do something like integer dot min value or max min value. Yeah. Okay, so you can take some random value basically and compare that with it. Let's say I'm taking the first element, then I'm checking it from the other elements. I'm saying, hey, if max value, if the current value array of I is greater than the max value, then my max value is equal to array of I. In the end, I just return the max value. What is it? Is there anything in this question? It should return me 23. 23. Let's say I want to get a maximum value in a range. So if I want it in a range, then I can create another function. I can just copy this. I can create another function, max range. I can pass a range over here, int start and int end. Now basically I'm going to say assume that the start one is and then you can say start from the start, go till the end. Nothing new. That is it. Don't even have to run this. It's very simple. If I try to run this, you can say max range from let's say index number 1 till index number 3. It should give me 23. 23. If I had 2 over here, then it should give me 9. Between this and this, which is the largest number? 9. So it's giving me 9. Okay, work with the edge cases yourself. Like when the array is null or empty or whatever, you can just add an if condition for that for yourself. Work on edge cases here, like array being null or whatever. Okay, so for example, some edge cases you can add over here is if end is greater than start. So here you can just say return -1. Okay, then you can say something like if ARR is equal to null, return -1, something like that. Edge cases basically. Here you can say if the array is empty. So you can say if arr.length is equal to 0. If the array is empty, just say return -1. Very simple. Adding the edge cases over here. Okay. Now using the swap function that we made, we can actually reverse the array now. For example, if I want to reverse this array, okay, so I can say static void reverse this array. I'll just pass an array over here. Now I want to reverse this array. How can we do this? We are going to use this swap function. So basically what we are going to do is we're going to have a start and end. Okay, and we are just going to swap these two. Let's see how we are going to do this. So if basically you want to reverse an array, so how can you do it? So if you have this array only, if you have something like 1, 3, 23, 9 and 18, have a start here and end here, swap these two. Then move start ahead by 1, end below by 1, swap these two. Move start here, end here, swap these only. So this is just a single element, it will be swapped. If you want to take an odd number of elements like 1, 2, 5, 9, 7, sorry, even number of elements, 8 or whatever, start here, end here, swap these two numbers. After that, it will be like 8, 1. Start will come here, end will come over here. Swap these two numbers. 7 will come over here, 2 will come over here. Start will come over here, end will come over here. So it will be like swap these two numbers. So this will be 9 and 5. End will come over here, start will come over here. Basically, we're just decrementing end by 1, incrementing start by 1. Our loop will end when start becomes greater than end. Now you can't swap it because start is now greater than end. And obviously this is done. This is my answer. Reverse of the array. Very simple stuff. Oh, notice you were not able to see. So let me just here reversing the array. Starting, ending, swapping. Start +1, end -1, swap. Start +1, end -1, swap. Start +1, end -1. Start becomes greater than end. Loop over. Okay, let's try to code this. Okay, so here I can maybe take my start and end. Also, I can say int start is going to be equal to 0. Int end is going to be equal to what? Array dot length, for example. But since here we are taking the index value, so array dot length will give me index out of bound. What is the last index going to be of end? What is the end index going to be in the array? It's actually going to be array length -1. If the length of the array is 5, last index is 4. That is what we're doing over here. What is the condition for our while loop breaking? While start is actually less than end, swap. So basically I can just call the swap function. I can say array index 1 is start and end. Just swap these two, then just do start ++ and end -. With the code that we wrote, we can see that this works both for even number arrays and odd number arrays as well. Let's try this out. Let's say we do something like sorry, not out. I'm just going to say reverse my array. Now when I print this, it should be reversed. So starting from the first one, then from the second, see it's reverse 18, 9, 23, 31, 18, 9, 23, 31. I add even number of elements, that will also be reversed. 56, 18, 9, 23, 31. This is known as two pointer method. We are using two pointers, right? Pointer 1 over here, pointer 2 over here. This was just an introduction. If you check out the link in the description of the syllabus, we have two pointer methods separately. We will be doing much more easy to lead code hard level questions in such particular patterns shortly in this particular segment only of the arrays. Let's look into what we are going to do next in the future videos. So I believe that was it for this session. We did some like basic stuff. We mostly focused on like the theory part. We did all the examples and everything we saw. Now the next thing is we're going to be doing some questions in a separate session. That session will be purely dedicated to questions only. Rotation of an array, Armstrong of an array, like palindromic array, and then we'll do some other questions related to sliding window, two pointer. We'll do so many questions in a separate session just because it's easier for you to manage. For example, in the future, if you want to learn about the theory of it, you can watch this session. If you want to practice some question, you can watch the question session. I think this is a very nice format that we are going to follow. So in the next session, we are going to be learning about sorting techniques, and we are going to be doing so many questions related to sorting techniques, and we'll be doing a separate session after the sorting techniques, which is called, we'll be doing sorting and searching after this, and algorithms based on that. After that, we'll be doing questions on like arrays, questions on searching, questions on sorting, and questions on searching and sorting we'll be doing in the searching and sorting sessions only. But the questions on the arrays and the questions on like more arrays, like patterns like sliding window, two-pointer method, using multiple for loops, and other questions related to your sub array questions, all of those we'll be doing as well in this particular module of arrays only. Thanks a lot for watching. Make sure you like, share and subscribe, and check out the links in the description, and I will see you in the next one. Bye.